How do we know that an athlete has had a false start? For a fair start, the runner mustn't begin to move until they have heard, then respond to the starting pistol. In a human, this response time is about 0.17 seconds. So if they begin to move in less than the time after hearing the sound of the pistol, they have jumped the gun and are guilty of a false start. Our reaction time does to some extent depend on what the stimulus is. The response time for sight and hearing are both slightly longer than for touch, as the brain is involved in processing the incoming data before an instruction can be transmitted for a suitable response. We respond to touch quite differently through the reflex arc, where the response is a reflex action mediated by the spinal cord and not the brain. Our reflex action to a touch takes about 0.15 seconds. To sound, it's about 0.17 seconds, and to sight, 0.25 seconds. Several things can alter the response time to a stimulus in everyday life: drug use, tiredness, or distraction. Let's look at drug use. You may recall that a drug is any substance that, when ingested, alters the way the body performs. Drugs that we commonly take might include nicotine from smoking, caffeine from beverages, and alcohol from drinks. Then there are a whole range of medications that are routinely supplied by medical practitioners. Drugs from whatever source may be classified as being a stimulant or a depressant. Stimulants are substances that keep the body awake and alert, and so may reduce body's reaction times. Depressants are substances that reduce the level of alertedness and so lengthen the response times. For example, caffeine is a stimulant and alcohol is a depressant. One simple way to measure how either drug use or distraction in the environment might alter your reaction time is to do the drop ruler experiment. One person drops a ruler between the subject's thumb and forefinger, which is placed at the 0 centimeter mark. No warning is given. The distance the ruler has dropped before being caught is read off the scale. This is repeated many times. Why do you think we need to do these repeats? Well, this is so that we can work out a mathematical average of a range of results. 10, for example, to reduce random errors that can arise in this or any experiment. The experiment would be done when the subject is in a calm setting with no distractions. This gives us a baseline result. Now, either give the person a strong caffeine drink like unsweetened coffee and wait a few minutes before beginning the test, or provide a distraction such as a loud noise or a TV. The experiment is then repeated and the results compared. Look at these results, shown for two groups being tested. What do you think the results show? Both seem to show that caffeine does improve your reaction time, but it would need a proper statistical analysis to make sure the conclusions are meaningful and not the result of chance. With practice, you can shorten your reaction time up to a point. But imagine the risk of drunk driving while texting and listening to music. Best not try that.